So you guys, we're looking at our nerds, right? And we have filled in this area under the curve. We filled it in. Does anyone remember how we notate that with our fancy calculus terms? How do we notate that area under the curve? Say that again, Dice. The integral, in this case, from where to where?
A to B.
A to B. And guys, I'm going to go ahead and name my function f of x. So are you cool if we say of f of x dx? So you guys, I want you to just remind yourself that that is just the area under the curve. Because we haven't seen it in that context in a bit. Okay? Here's why I gave us some nerds. I now want to know what is the average value of this function. And the values of this function are in terms of this function f of x. I'm just asking, what's the average y value on this graph? So what I want you to do with a straight edge, maybe your pencil, is I want you to go ahead and smush all your nerds, and I want you to bring them down, and I want us to bring them down until we create some kind of rectangle where this area is now compensated over here. So I want you to squish the nerds down and form a perfect rectangle, still from A to B. Still from A to B. Let's go see it. Do we still have the same area?
Yes.
Yeah, we should, if your name is not Nelson. Okay, we should have the same area. And it's just like saying, oh, okay, that area is just represented in different shape. You guys, what part of this rectangle represents the average value of this function, would you say?
Where it touches the point of inflection.
Where it touches the function, I agree, which represents what part of this rectangle? This would represent the
Middle.
It maybe looks like it's in the middle, but it's the what of my function. Thank you, Soph. It's just the height. It's just the height. So you guys, now you can start eating your nerds. Now you can start eating it. And here's what I want you to think about. We know the area of a rectangle is what times what? Guys, what's the area of a rectangle? What's the formula for area of a rectangle? Length times width or base times height. I'm going to go with base times height. You can be eating your nerds as we go with this. Okay. The area of the rectangle. Do you agree the area of the rectangle is still the area of what we had before, which was the integral from A to B of my function? You guys are okay with me substituting in that the area of the rectangle is the integral under the curve?
Yes.
Okay, thank you, Graham. I appreciate some affirmation.
Got you.
You guys, what would be the base of my rectangle if we went from A to B? Yeah, isn't B represented by this distance here? Minus A's little distance there would get me B minus A is the base of my rectangle. So we got that's my B minus A. So I'm going to replace base with B minus A. I'm just doing some substitutions here. This area of the rectangle got replaced with this. I'm substituting base for B minus A. And you guys, how could I call height? Exactly. Thank you, Dice. He's saying f of x, the value of the function, that's my height. So I'm going to replace my height with f of x. I'm going to highlight that there. Just let us know all those. That's where all those came from, that substitution. What AP loves to ask for is what is that value right there? What is that average value? What is the value on my function? They want f of x by itself. How could I get f of x by itself in this equation here? Divide out the b minus a. Exactly. You guys, if I divided out my b minus a, I'm with you, it'd cancel right there. Dividing by b minus a, you guys think about what we just did with differential equations. Instead of writing it all over b minus a, could I bring it out front as thank you. He says it could just be 1 over. You guys are blowing me away on this Monday. 1 over b minus a times the integral of my function is going to get me my f of x. And this f of x is just referring to the average value of my function. This is what we want to take away. So you guys, let's make a prediction. Let's make a prediction. Let's go take a peek at this graph here. And my question is, what's your prediction for average value? Guys, anyone have any idea what y value is going to be the average value on this function? Meaning, if I've got the area under this cute little parabola, I'm curious what y value would make a rectangle have the same area as this area. Say that again, Sammy. You're thinking 4. Let's see what that might look like. If I went up 1, 2, 3, 4, do you guys think if we made a rectangle that this area would be offset by this area? Do we feel pretty good about her saying, I think this y value of 4 is going to have the same area? Anyone have a different guess? Or you're like, I feel good about Sammy.
I feel pretty good.
We're vibing. Sam, looks like they are down with you. Let's go take a peek. So we're thinking that it's going to be 4. That's our prediction. I'm just going to put it up here. All right, you guys, to find average value one more time. It's always 1 over that b minus a. Where do you think we're going to get that b and my a based on this picture? 3 and 0 are my b and my a. So anytime they give you an interval, you guys, we got a and b. So this is my a, this is my b every time. So we're going to say 1 over b minus a, which is just 3 minus 0, yeah? Or just 1/3. Integral of antiderivative, love it, Sammy. What are my bounds? Again, there's still the same bounds of a to b. What's my function in this case? Yes, people, dx. If you forget the dx, AP is understanding. Okay, so you guys agreed that we got a 1/3. No, we're not getting our calculator. We're going to do this by hand on this beautiful Monday. My 1/3 is just chilling out front, guys. Let's go take an antiderivative of the x squared. That's going to become x to the what over what? X cubed over 3. Antiderivative of 1. Love it. Guys, again, that 1/3 is just chilling out front. We need...
No, because they're bound.
Exactly. If we didn't have bounds, and even if we did put a plus c, since we're going to do an upper minus a lower, it'd be plus c minus c, and they're going to cancel out anyway. But I love where your head is. You guys, we got to go evaluate in terms of upper minus lower. Boom, minus boom. He's saying, all right, I got a 1/3. 3 cubed gets me 27 over 3. 27 over 3 is 9 plus 3? 12. Minus my lower. Yeah. He's like, I don't really need it. What's a third of 12?
4.
Sammy's guess was 4. Sam, A plus girl. So maybe we just show ourselves what the heck does that mean? If we went up 4, what that's saying is that this red rectangle has the exact area as this black area under the curve. How do you find the average? If I said, hey, what's your average grade in this class based on 3 test scores? What would you do? Add them up and divide by how many tests I gave you, right? You guys, what is this? Does anyone remember what this integral symbol means? Summation, adding them up. This is when we were doing like Riemann sums, adding up those areas under the curve, adding up those rectangles. So we're adding them up. What's multiplying by 1 over 3 the same as? Dividing by however many tests we had, right? So this is just like what you guys have done since 4th grade, finding averages, adding things up, dividing by how many things we are added up. This is just in calculus terms now. Okay, peeps, let's go try this one, and I'm going to let us use our calculator. But let's talk about the setup of this. What's my A and my B? Yeah, so what are we dividing by? 1 over pi over 2. Yeah, minus negative pi over 2 would just be plus a pi over 2. Well said. Yeah, 2 pi over 2 would just be a pi. Very good. So we could simplify that. Or we don't have to. Up to you. What are my bounds going to be on my integral, on my summation? Negative pi over 2 all the way up to pi over 2. Very good, you guys. What's my function? Beautiful. We could do this by hand, but just for time's sake today, I want us to practice in our calculator. All right, so let's go calculate. Guys, we got to make sure that we are in radians. If you are taking the ACT tomorrow, I would go back to degrees because they'll have like an SOHCAHTOA question on there, I'm sure. They could ask you radian questions as well, but they ask you typically more degree questions. I'll remind you at the end of the period. You guys, let's go type this in, either one of these. Anyone remember how to get that integral sign? Yeah, so we're going to do 1 over pi 1 over pi, math 9 it, from negative pi over 2 all the way up to positive pi over 2. And then we've got 2 cosine of x. Anyone else get a little 1 point something? Love it. And how many decimals do we have to put?
3.
Love it. 1.273. Number 3, find the average value. Okay, this one I'm going to ask us not to use a calculator. Let's do this one by hand.
1/2.
Yeah, he's saying, all right, then I got to do 1/2. And some people like to do it this way. They like to say the divide by 2 that way. I'm totally fine with that because this kind of helps you see, oh, we're adding things up and dividing by how many tests that we took, if you will. But dividing by 2 is the same as multiplying by 1/2. So whichever way you want to write it. You guys, what are we going to do our bounds from? 0 to 2. And what's my function?
8x minus 3 plus 4.
Beautiful. Dang, remembering that dx, we are showing off today, and I'm here for it. Oh, sure did. Thanks, guys. And you guys, that's what, I'm so glad that you're comfortable with correcting me. Do the same thing with Miss Queen. We're not perfect. Jump on in, just like you've been doing, which is important. Antiderivative of 8x.
4x squared.
8x squared over 2 exactly is going to get me 4x squared. I love it. Minus 3x. Antiderivative of 4e to the x. We love 4e. We love e to the x. Yep. From 0 to 2. Guys, this is free response. Do we need to simplify it?
No.
No. Let's just plug those in and leave it. Who cares? That 1/2 is chilling. You could write 4 times 2 squared, or you could write what? 16. Either way, doesn't matter. Whatever you want to do. Minus, plus, 4e to the, wouldn't it be to the second? Because I'm plugging in that upper bound?
Yeah.
Then be careful, because we might get lazy here and be like, oh, minus 0 is going to be just 0.
No.
That 4e is a nuisance. So I could put minus 0, but what do we really need to put? Minus 4e to the 0. Because what would that actually be? It'd really be minus 4 times that 1 to get me a minus 4 there. So you could put this, you could put minus 4, you could put minus 4 times 1, but we cannot put just 0 over here. Sound good? We done?
Yes.
Cool. Don't be scared. This is from 2016, and so this funnel is a maximum of 10 inches high. We've got these cute little cross sections. The radius of the funnel is given by this equation. You guys, what happens to the radius as I go higher up in the funnel? It gets bigger. And what happens down here? Okay, great. And it says find the average value of the radius. What is the average radius length is what they're curious about. You're like, okay, average radius. I just need to add all my radiuses up and divide by however many inches we're dividing this through, right? So what would that average value look like? 1 over 10, because it's 10 minus 1. Or Bondi's going to put all the things divided by 10. And Bondi, that's great. My integral goes from blank to blank. Beautiful. Yes, 1/20th, because my function is 1/20th 3 plus h squared. Now here's the deal. Look at this. This is the worst part. Yeah, only questions 1 and 2 are we allowed to use a graphing calculator. So what I want to start with, you guys, is just learning kind of the cheat. Could I distribute my 1/20th in? Sure. But it's a constant. And when you've got a constant with an integral, take it out front so we don't have to deal with it. Does that sound good? So I already had a 1/10 out there, and I could just say times that 1/20th. Make our lives easier. Or you could have just said 1/200th. Either way, they're good with it. Sound good? It's just going to make our lives easier. Antiderivative of 3. 3h. Well said. Antiderivative of h squared. Thanks, Sam. From 0 to 10. That was a huge lifesaver. So, because we could have done this, my antiderivative would have been 3h over, or 3h, anyway, over 20. This is just going to make our lives easier. Let's go plug in that upper and lower bound. And what happens to my 1/200th? Yeah, it's just chilling. 1/200th, and I'm going to put some brackets. I don't care. I feel like you guys don't like brackets. You like parentheses. I just like them to let myself know he's really chilling out front. What are we going to say? 3 times 10 or 30? I don't care. Plus 10 cubed over 3. I'm not going to mess it up. Minus 0 plus 0. We don't even need it, right? We're done. We're talking about a 12,000 liter tank. That's big, okay? Bigger than your Stanley. It's filled to capacity. At time t equals 0, water begins to drain out of the tank at the rate modeled by R of t. And this is a rate. This is a rate liters per minute. It says find the average rate that the water is draining between 0 and 8 hours. This is already given in hours. Phew. So you guys, do you agree that we need, I agree, that's my A and that's my B, Mr. Nels. So we want really the average 1/8 of my R of t dt, right? That's what we want. But how are we going to find that? She's saying we got to separate it because the rate apparently changes as the time goes on. For the first 5 hours, the rate stays consistent, right? So that 1/8 is what I need to be chilling. My 1/8 is chilling. How am I going to split this up then? Yes, from 0 to 5. Of what function? Exactly, Stevie. 0 to 5 of what function?
600t over t plus 3.
Beautiful. Plus, what other average do we need to add up there?
5 to, I don't know, what's the highest it can go?
5 to 8
Or 8.
Exactly, since they bound it to 8.
of 1,000.
Of 1,000 e to the negative 0.2t dt. My calculator can't handle this. I think yours can. Mine won't let me type 2 integrals in one. So you guys, we want 1/8 of that whole thing. Because, right, we're really dividing by 8 hours. So that's why we're going to say 1/8 of the whole thing. But we need to add up my different amounts of water. 258.053.